Welcome to another problem session. So this is my second problem. I finished up the first one and posted it. Okay, so this is actually another good problem. You can read it. So this is on a table, and there is this thing is actually a ring. It's kind of a ring. This green thing is a ring. And the inside surface, there is a block that just fits in here and sliding along the ring. So that's the setup. And the coefficient of friction is mu, and there's a kinetic because sliding. And radius, I'm going to take a L rather than R. You'll see that I'll use the R in a little bit for just a generic radial coordinate. Okay. So now this is a circular problem, circular motion problem. So naturally, you would want to see if polar coordinate will be appropriate. Okay. And it turns out in this question, polar coordinate is very helpful. All right. So it's saying, what's this? If the speed was v0 at t0, what's the speed later on? So it's asking about the speed, but F equals ma is all about vectors. So when we set it up, we probably have to be very careful about the direction and things like that. Okay. And then it's asking where the relation will be. Of course, when over here, if you draw coordinates, then at t equals 0, suppose on the x-axis, suppose you draw a coordinate like this. So this was like an x-axis, and maybe this is the y-axis, and of course the z is coming out above the table. And over here the velocity will be tangent. So velocity vector, so this at instant t is over here. So it say this was over here at t equal to 0. So I'm free to choose where t equals 0. So in this case, at this point, it is angle phi. So if I can give you angle phi, then I can definitely locate it, right? I can give x and y coordinates. So this is a question about if 0 is 0, then what will be 5t? That will mean actually if you want to figure out x and y given in this way, then x will be just L cosine phi of t, x at instant t, and y at instant t will be L sin phi t. So this is like a polar coordinate way of thinking. And if it's tangential this way, I see my cursor is not lined up, actually highlighted. So I'm going to go out and get the turn off and turn on again. Now I have the cursor. All right, good. I got the cursor. All right. So you can follow my cursor now. So let's where was I? So this is if you look at the polar coordinate, this is a radial coordinate, and this is the angle coordinate, right? So if I'm writing the velocity vector at time t. So let's look. You can see the g you can ignore, right? G is down like this, so we don't need to worry about g. So okay, I will continue draw this way, because it's hard to see a circle here. So here's a circle. So I'm over here, and x-axis is this way, and y-axis is that way. So if I'm over here and it's going this way, this is the so-called phi hat direction, right? The unit vector, which is also unit like that. These are unit vector directions. So this is also called tangential direction. So velocity is tangential, it's in that direction. So if this is angle phi, then these guys are like phi hat is going to be minus sine phi I hat plus cosine phi j hat. And if while I'm at it, although I will not need it, if you go from this origin straight through at this point in time and keep going in that direction, that's called radial direction. I've done this before, and with maybe some review, we call it r hat. Sometimes we call it u hat of along the r direction. So these vectors are it's going to be cosine phi I hat plus sine phi j hat. So you can see that this phi is changing in time. So this is a function of time. So this is a function of time. These guys are pointed the same way. I hat is always pointed this way, and the j hat is always pointed this way. But this guy, because these guys are time dependent, I expect them to be time dependent. So it will be like that. Okay, so the velocity is pointed that way at this time, and is got the magnitude v as a speed, which is a function of time. So velocity vector can be written at time t will be v at time t, that's the speed part, and then in the direction, tangential direction, which also is time dependent, right? As we said over there. So the acceleration in this case at time t, I need this. Why do I need this? Because I want to write F equals ma, from where I will look at it how to solve for this problem, because that should have the information rather than guess what the speed will be right away. Now if you try to guess the formula, I guarantee you that, like, unless you already know the answer, you're going to get 99% mistake, okay? 99% of the time you're going to get mistake. So bear with me, you got to learn these steps so you can actually don't make a mistake. You don't make a mistake, all right? So this will be just the derivative of the velocity vector, not this guy alone, okay? That's where the mistake comes in. So velocity vector, I got to take derivative, only then I'm going to get acceleration. And so when I put this there, this tangential part also becomes derivative. Plus v remains there, d phi hat dt. And I go over there and say, okay, what will that be? D phi hat dt. Well, that's going to be minus cosine phi d phi dt, but I had, is constant, so not going to make any difference. Minus sine phi d phi dt j hat. So if I take a minus d phi dt common from there, what I left over here is just the r hat part. So that's the r hat part, and which is a function of time. So we got this. So we can replace this. So acceleration has a radial part and a tangential part. Phi hat part and minus v d phi dt r hat part. So it's got a radial part and a tangential part. So sometimes you see this, you're going to say radial is this quantity minus v dv dt, and a tangential is this part, which is dv dt. Sometimes you have it, tangential part sometimes you call at, sometimes called a radial capital R. It's kind of denoted like this several ways. So all it is which part goes with what. Now I have to work on the F part. So what are the forces on this? Well, the ring, we're going to push on it. So normal will go this way. So this is normal. And because going this way, your friction will go that way. And of course the gravity is down the table, is 90 degrees to everybody. So it doesn't participate in this acceleration, right? So gravity is down, and so this is mg, and there's another normal from the table upward. So there's a normal, let's call it n2 upward. So this n2 and this mg, they cancel out, right? They're going to cancel out, and we are left with here's a circle. I'm over here, and this is the center. Towards the center, opposite the radial direction is normal, and this is the tangential direction. This is the phi hat direction, but opposite to the phi hat, this is where the velocity is pointed. So opposite velocity will be the frictional direction, and because this is kinetic friction, they're 90 degrees to each other here. So this is opposite. So n is minus n r hat, but if kinetic friction is minus kinetic friction phi hat, and this part is mu times n, so minus mu times n phi hat. So these are two forces that are in the plane of the table, and so this must equal to ma. So you got a minus n r hat minus mu n phi hat equals to minus v d phi dt r hat plus dv dt phi hat, the whole thing multiplied by mass m. Okay, so I make it r part equal to r part and phi part equal to phi part, because they're 90 degrees to each other. So just like x becomes x, y goes to y, radial goes to radial, and tangential goes to tangential. It's the same thing. Okay, so I've got a minus n is equal to minus mv d phi dt. I got a minus mu n equals to m dv dt. So I can proceed several ways here. The one I like to do is just divide, get a mu out here. So mu this over that, m dv dt, mv d phi dt. And right away I see the dt's cancel out, m cancel out. So this is pretty easy. So it becomes dv over d phi. So mu equals to 1 over v dv over d phi. So I can bring this guy on the other side. These guys are all v on this side. So dv over, this was a minus and this is a plus. So I would have a minus out here. Minus dv equals to mu d phi. Might as well bring this minus on the other side. So I'm going to integrate both sides. So I want from t equal to 0 to some t equals to t. Let's see, we have picked phi to be at this point. It was originally here. At that point v was pointed that way. So v was v0, and I'm using v for the at time t. And this is dummy. So if you want to put a v prime here, there's dummy, and this is dummy. So phi was 0 when that was the case. This goes together, and phi will be phi at time t. So this just a log v prime v0 v, and this is minus mu phi prime 0 to phi, and so this is log v over v0 is minus mu phi, and that v over v0 is e to the minus mu phi. So v at times t is v0, which is at 0 time, e to the minus mu. So it seemed like a speed is getting, but this with the phi. I want with time, right? So I need to know this with the time. So this is kind of a not done yet. Okay, so like it's some kind of implicit equation. I want explicit in t. Okay, I want vt is some function of t. So I need to figure out phi equation. So how are we going to get phi equation? Well, actually, you will see phi equation can be independently obtained. So I'm over here at phi so this is at t. I'm over here at 0 time over here. So this is phi, and this is L. So phi of t is going to be let's see, I got L theta, so or L phi. I'm just originally work out theta, so now I'm going to work out phi. So if this is L, this distance, so in any small amount, L d phi, so this increment, a small increment, okay, L d phi will be ds along the arc. So what do we have? We get L d phi dt will be ds dt. So this is the speed, and we're saying the speed at time t. So this is at time t. So this is the v at time t. But this one is in terms of phi. So we can write that in terms of phi is v0 e to the minus mu phi. So this phi is same as that phi. So we're looking at the phi and little instant dt here around t to t plus dt, and we examine that, and it looks like this. So I've got a how do we solve? So this is d phi dt is v0 over L minus mu phi. How do you solve this? Well, this is again just like over there we put these guys together, the v's together and the ph's on the other side. So over here I have a t variable and a phi variable, and the phi variable is over here. So I'm going to bring this on the other side and tt on the other side. This is a common thing called separation of variables. You separate the variable from two sides, and then you integrate, and the integration would be much easier to do. So we got a d phi e to the mu phi, because when on the other side becomes a plus, equals to v0 over L, this constant dt. And we need to think about integration limits now. T will go from 0 to some t. So this kind of a dummy variable, that's the regular fixed value t. When it is 0, we have said this variable has 0. When this is t, we have saying this variable has phi. So this becomes e to the power mu phi over mu, and 0 to phi, and this is v0 over L, t minus 0, and we can just say mu on the other side. So e to the mu phi minus 1, because of this becomes, you can have minus 1 mu v0 over L t. So we know e to the power mu phi 1 plus mu v0 over Lt, and this tells you that the mu phi is log of 1 plus mu v0 over Lt. So phi itself is 1 over mu log of 1 plus mu v0 over Lt. So we know the position. So we solve the second part first, right? So this is the second part. So we know position. We also know what e to mu phi is from these guys, right? And over here, I need e to the minus mu phi. So v of t was v e to the minus mu phi. And we have e to a, I need minus, we have a plus here. So this will be 1 over that. So v0 over 1 plus mu v0 over Lt. So now this is explicit t. So this is the answer for v of t. So this is the speed at instant t. And you can say this is the position at instant t. Oh, that was a long algebra, and some of you may find pretty hard. I don't think this is a good problem for MCATs. I think it's a little bit hard side. But for JEE, this is a probably expected, that you should be able to do this this much manipulation. For MCAT people, what is the lesson here is you can separate into tangential and radial part, and sometimes that technique is very useful in simplifying the problem. Okay. So if you like this kind of detailed explanation of things, maybe tell your friends. So you can definitely tell your friends. And maybe subscribe to this channel. I've been gone for last week. Had a family thing, and now another family thing coming up this coming week. So I may be writing actually posting these videos, but I intend to post throughout the fall semester, maybe one video a day. So if you subscribe, you probably will get notification of when my postings are happening. Okay, thank you, and see you in another video. Bye.